Welcome back. This time I want to show how to create a graph component in Kotlin using Jetpack Compose. And on screen you can see some example of what we can create when we're done. We start with an empty project where I have removed the Hello World template code. And I will create a function named graph, and it will be composable. And as always, we will take a modifier as an input and also give it a default value. This is so we can, for example, give our graph a size. I will give it the max width and put the height at 600. Our graph will be based on a canvas, so we create one inside our graph and give it the modifier as a parameter. I will create the equation that we will want to start drawing. So let's try out sinus, and we need to give our graph area some mean and max values for the axes. And I'll start with x going from 0 to 2p, so we can see the whole sinus wave. And in y we go from -1.1 to +1.1, so we can see the whole amplitude of the sinus curve. I also want some helper functions for converting values from pixel values to values on the axis. So from x value to value on the axis, we create pixel to x. And for converting our y value to a y value on the screen, create a helper function for that as well. And finally, a helper function that connects all these pieces together, so we can give it a x pixel value and get back a y pixel value using all the previous functions together. And now we can try to use them. I will draw the wave as a path, so we start at the 0x pixel value and call our function. So we get a y value from it. And then we do the same for all the pixel values from 0 to whatever width our graph have. And then we add a piece of the path between each pixel value. And now we can draw our path on screen. I'll pick a color. Let's make it blue. and we also can decide what style the line will be in. I will just draw a line with a width of 3. And now we can preview our graph and we can see our sinus wave. Next we will generalize the code a bit so we can reuse it. First we create a axis interface, and it will need the min value of the axis and the max value of the axis. We also need 2 functions for converting values on the axis to screen pixels, and the other way around, from screen pixels back to axis. And let's create a horizontal axis. It will inherit from the axis. And as parameters we will take the mean value and the max value. And we also need the number of pixels on screen to calculate. And then we implement the 2 functions. We kind of already have the code for it down here. We just modify it to be for the horizontal axis. And we do the opposite for the 2 pixel values. Next we do the vertical axis. It's almost exactly the same, except that the vertical axis starts from the bottom and go up, so we have to revert it, so we take away this screen size from the values. And now we can use it in our code. We create a left axis. It will be a vertical axis. And give it the height, and then we create the bottom axis in the same way, but now a horizontal axis, x min, x max, and the size dot width this time. We take away the old functions and replace it with the functions from the axis instead. And it should look the same. Next, I want to send in a few parameters to our graph. The equation, or the f, the function that calculates the equation that we want to visualize. It will take a float and give it back a float, just as sinus. And we also want the boundaries of the axis. So the x min, y min, x max, and y max. And we give it some default values, 0 to 100 on both axes. And now we can send in our values to the graph instead. So we have the sinus function. And the boundaries of the axis. should still look the same. Next thing we will do is make it possible to add multiple lines to our graph, and we kind of do it with just making a list of our float to float functions instead. And instead of calling f here, we will loop over our items. So for each item we'll call it f, and we will do exactly the same thing for all of them. So now we should be able to add a list of functions here instead. So let's keep sinus and add cosinus as well, cosinus. And when we render it, we see both the sinus and the cosinus curves rendered. But they have the same color though, so let's fix that. I want to create a class for the function. Let's call it the equation line. So we give it one color and the function that we want to draw. And this class will have one function that is used for drawing our equation. It will take a draw scope, draw scope from the canvas, and also the two axes, the left axis and the bottom axis. And the code in here is exactly what we have down here in the graph function. So we copy it and make sure we can use it. Here we want the size of the axis. So let's expose that in our axis interface as well. It can be an int. And the draw path is a function on the draw scope. If we use the with function around scope, we can use scope as this parameter. And let's replace our list of floats to floats with equation line. And in our code now we can instead call for each item the draw function with the scope and both axes, and that should replace all this code. We also need to convert these to ints. And now we will replace our old lambdas with the new class. So we call the equation line class with a color, let's say blue, and we keep our sinus and copy it and make another one for the cosinus. And we make that one green. Now we can run it. It did not work because we forgot to use the color parameter, and there we have it, green cosinus and the blue sinus. Now I want to show you something else. If we put a graph in a column, so that we can add a little text above it, I will just say the graph header and render it. We see the graph header above it, But if we now change the y max to be like 0.5 instead and render it, we see that the curves render above the label text. So we have to clip the rendering so it doesn't render outside the graph, and that we do with the clip rect function. So you do that around whatever we're drawing, and now when we render, it will render correctly. Next step is to generalize the function a little bit more. So we create an interface called graph item that the equation line implements. It will only have the draw function. And we change the signature of the graph. This makes it so we can add other kinds of lines to draw, or any graphic component actually. Let's try out with an XY plot first. So we take a color and a list of points on the form of offsets. And we make it implement the graph item interface. And now we can draw our points. We do it within the scope of scope. So we take a path and we take the first point of our list and we convert it to screen coordinates using our axes. So the x value we convert on the bottom axis, and the y value we convert using the left axis. Then we do the same for the rest of the points. So we drop the first one, which we already added, and then we do for each of the other points in the same way as we did for the first one. And then we draw this path. So let's use this new graph item to the XY plot. So we just add it to our list of graph items. And let's make a red line, and we give it a list of offsets. Well, start with a 0.0. And then just give it some more random points. There we see our new XY plotline rendered in our graph, and that's what I wanted to show you in this first part of this graph component. In the next part we will render the axis as well. Thank you for listening.